Hey, welcome to part 2 of our lesson 1 through 8 review. First off, why couldn't the angle get alone? Think about it, think about it, think trig, think trig. All right, hey, sorry for the touches on my stylus here. They come up through the microphone, but that's just something we're gonna have to deal with until I use a headset or something like that. But for now, it works. All right, here we go. Next problem. A little more transformation. Looks like this first one, you can see that it is a translation. And we've already done a few of those, so I'm going to let you work on that one and check the key when we're all done. And this one right here, we've got this little minus x and y. If you remember that when one of the coordinates changes sign, that is a reflection. I'll let you decide which axis it reflects around and go from there. All right, next up. Table below. This is kind of like an in and out table when you were looking at functions originally. You're just looking for patterns. So you're trying to find some patterns for both the x's and the y's. All right? So if you look at the x's, 2 to negative 3, 4 to 5. Okay, there's nothing. If you don't find that, you're looking at switching patterns. So if you don't find any kind of a pattern like a plus or minus, or a multiplication pattern, which would be a dilation, then you're looking at the next step would be switching. In this case, 2 and 3, negative 3 switch places, check. 4, negative 5 switch places, check. 4 and 5. And then you can probably fill in the blanks all the way down till you finally get a nice concise description in general. That's the holy grail right there. All right, keep going on that. Same thing here. We're looking for patterns in the x's, patterns in the y's, switches. So we're looking for patterns. Oops, let's get that out of there. So we're looking for patterns. We're looking for sign changes. We're looking for switches. And we'll notice that 5 to 2 is minus 3 in the x's. Negative 3 to negative 6 is minus 3, and also onward and so forth. So that's the x pattern switch, and I'm sure you can probably figure out the y pattern switch as well. So check that out. Wrap that one up. Let's see what else we got. A little more on the transformation rules. Right here you can see number 1 is a translation. So just move that triangle, all the coordinates over. The second one is a switch, y to x. So you're switching y to x. If you remember, that is a reflection, actually, I believe, across the y equals x line. So you might think about it that way. It might reflect just like that. There's the y equals x line. So it might help you out a little bit there. The last one is a dilation. So the last one you're multiplying. You got a scale factor of 1.5. And it reflects around the origin, which is 0, 0. Okay. Hey, so show for each one of these, show each step. And you may want to put down the coordinates. You may not. It's up to you if you want to like start listing coordinates for all the 3 points. And then go to the new points, new coordinates. That's up to you. If you like more of a visual approach, you can do that, or you can do it right on the graph. Moving right along here. Center and radius for a circle. Let's see, what have we got on the first one? You remember the formula. H goes with x's, and it's the opposite sign of what you see, so that would be a center of 1. And with the y's, if there's no adding or subtracting, you are looking at k being 0. So that's, you can get those coordinates real quick. Remember, the radius isn't 9, it's square root of that. That's r squared, so it'd be 3. Okay, parabola, same distance. That's the key there, is it that same distance from that focus point to the directrix. Let me just take a look at my notes real quick here, see what I can give you on that one. All right. So what you're going to want to do is you can use focus directrix form to figure that out. You've got focus directrix form. Remember, it looks like this: y minus b squared equals x minus a squared plus y minus c squared. I think I got the b and the c right there. I'll change that if I need to. But that's you're checking out the distance between each of those points and the focus, and the distance between each of those and the directrix. If the distances are equal, you must say they're correct. So I'll just say distance 1 and distance 2. So you can check out the distance along there, or you can use the formula. There's a variety of ways to do those. So probably expect a few questions on that problem in particular. But when you look at the answer key, you'll probably see why you can tell. All right. Equation of a circle with a center and radius. Okay, that one, I think, look back up at the center radius form, and I think you'll probably be able to write that equation pretty quick. I'm just going to frame it real quick. And then you can fill in the center and the radius there. All right, select all equations which describe the parabola with the focus and the directrix. This one's going to be a little bit tougher for you, most likely, because you can use the focus directrix form, and you can also use the vertex form. But if you do know this one, like right away, you're looking at this A format here, and you're saying, look at that, there's that -1, there's that 7, there's that 3. If that's the right format, you can use that. And then to get to one of the other forms, you're going to have to do the same thing we did, and I believe it was lesson 8 or 9, where you actually have to expand and convert from one form to the other. A little bit of algebra involved. There may be some shortcuts to that. If you find them, don't worry, when we do the solutions video, we'll take a look at a few shortcuts to that problem. So we'll take a look at some varieties. And it looks like that's it. We'll let you go off, and at that point, email with specific questions, or join the Zoom chat later today. All right. Have a good one. Bye-bye.